Okay, so we're going to continue the topic of functions today, and we're going to deal with the inverse of a function and the one-to-one functions. Okay, so a one-to-one function is basically a function is one-to-one if every element is y is mapped onto one and only one element in x. Okay, this means that no two x values give the same y value. Remember, we said that for a function to exist, right, it is okay if every if different x values give the same y values. Okay, but for a one-to-one function, every x value must give you a different y value. If two x values give you the same y value, it is not one-to-one. Okay, so it's that's pretty much it. So again, only for one-to-one functions. Okay, so a one-to-one function is a kind of like a subset of the broad topic of functions. Okay, and to determine if a function is one-to-one, we have two ways to do this. The first way is to find f of a and f of b and then put them equal to each other, and if you could get a being equal to b, then the function is one-to-one. Or you could also do a horizontal line test. Okay, which is where you sketch the graph of the function and you draw a horizontal line, and if it cuts the graph more than once, the function is not one-to-one. Now remember to test if a function, if the graph, if it's a function, we normally do what? We do the vertical line test, okay? But if you want to test if the function is one-to-one, you do a horizontal line test. So we're going to examine these two methods here now, right? So we're going to have f of a and f of b. Okay, so we have y is equal to x squared. So let's do the first test first. So we find f of a. So we say let f of x be equal to x squared. Okay, then we find f of a, which is equal to a squared. We find f of b, which is equal to b squared. Okay, so then we put them equal to each other. A squared is equal to b squared. Okay, then we basically try to simplify it, and if we get a to equal to b, then the function is one-to-one. So what we're going to do is we're going to find the square root of a squared is equal to the square root of b squared. But notice, you might think, okay, well, this means that a is equal to b, right? But that is not the case. Because remember, the square root of a squared could be plus or minus a, and the square root of b squared could be plus or minus b. And this is not the same as having a equals to b. So therefore, this proves that it is not a function. Okay? Not a function. And let's say now we wanted to draw the graph. Okay, the graph of x squared looks like this. Okay, and what we're going to do is we're going to draw a horizontal line, and notice this horizontal line cuts the graph in more than one place. Therefore, this also proves that it is not a function. Remember, for it to be a one-to-one function, sorry, not one-to-one, I'll say not one-to-one, not one-to-one, that's my bad, yeah. Okay, again, we're testing if the function is one-to-one. Okay, notice that this graph passes the vertical line test, but it does not pass the horizontal line test. So therefore the graph is a function. Okay, so y is equal to x squared is a function, but it is not a one-to-one function. Okay, because if we look at the values plus 2 and minus 2, when x is equal to plus 2 and minus 2, if x is equal to plus 2, y would be equal to 4, and if x is equal to minus 2, y is equal to 4. Okay, and for a function to be one-to-one, this cannot happen. Each x value needs to give you a different y value. Okay, so as a result, this is not one-to-one. In the next question now, we have y is equal to, let's say, x plus 4. Okay, so doing the test, we say let f of x be equal to x plus 4. Therefore, f of a is equal to a plus 4. F of b is equal to b plus 4. Next thing we do, we put them equal to each other. A plus 4 is equal to b plus 4. Okay, and then we try to see if we get a equals to b. Now if we minus 4 from both sides, we will get a plus 4 minus 4, which is 0, and then b plus 4 minus 4, and you'll just get b. And as you can see, we could prove here now that a is equal to b. Okay, therefore it is 1 to 1. And a 1 to 1 function is called an injective function, so therefore we say it is an injective function. Okay, so if we to draw the graph too, let's draw the graph. Okay, graph would look something like this. Okay, where here is 4. Okay, and again, if we was to do the horizontal line test, notice if we draw a line in this graph, it only cuts at one spot. Okay, and this means that the function is 1 to 1. Okay, so continuing now, so this is basically 1 to 1 function injective functions. Each x value gives you a different y value. If two x values gives you the same y value, then the function is not 1 to 1. Okay, and now we're going to deal with the inverse of a function. Okay, the inverse of a function is denoted by f to the power of minus 1 of x, right? It's not really to the power of minus 1, but this is how we denote the inverse of a function. Okay, now for the inverse of a function to exist, it must be 1 to 1. If the function is not 1 to 1, you cannot find the inverse. Okay, for an inverse, the domain of f of x becomes the range of the inverse function, and the range of f of x becomes the domain of the inverse function. So it kind of switches. Okay, and basically what the inverse of a function does is, normally, remember, we use a x value, sorry, to get a y value. What this does is it switches it. So basically you starting off with this value here and you want to get this value. Okay, so you go in, normally you go this way for a function. Now for inverse of a function, we go in the opposite way. Okay, and last thing about inverse functions, the graph of f inverse x is obtained by reflecting the function along the line y is equal to x. So for example, let's say we have a function. Okay, this is the line y is equal to x. Okay, passes through the origin. Okay, let's say I have a function here. Basically, sorry, okay, no, not that one. Let's say there. Basically, to get if you want to draw the graph of the inverse function, we just reflect it along this line, because this line is y is equal to x. We just reflect it along that line and we get the inverse function. Okay, so if you want to draw the graph of an inverse function, just reflect it along the line y is equal to x. Okay, so again, if we have 1 mapping onto A, 2 gives you the letter B, and 3 gives you the letter C. Now we're starting off with A and we want to get back 1. We're starting off with B, we want to get back 2, and we're starting off with C and we want to get back 3. So basically, this is the main thing you need to know about inverse functions, is how to find the inverse of a function. So let's say I give you f of x is equal to x plus 4. Okay, it's some very simple steps we have to follow. Okay, first thing, if you want to find the inverse of a function, we say let y be equal to the function. So we say let y be equal to x plus 4. That's the first step. The next step is to interchange x and y. So wherever you see x, you put y, and wherever you see y, you put x. Okay, therefore we have x is equal to y plus 4. And the last step is to simply make y the subject of the formula. Okay, so to make y the subject of the formula, we have y is equal to x minus 4. Okay, now don't leave it like this, right? All it says therefore, these 3 circles means therefore f inverse of x is equal to x minus 4. Okay, that's all that means. Okay, so if we have f of x, right, and let's say we substitute x as 4 in here, right, let me say here we have f of 4. Okay, f of 4 will give you 4 plus 4, which is equal to 8. Okay, all we will do here now is the inverse function. Okay, if you want to find f inverse of 8, okay, it'll be 8 minus 4, which is equal to 4. So it basically takes the y value, you can see, and give you back the x value. Here we're taking the x value to give you a y value for the regular function. For the inverse function, we're taking the y value, you would say, and getting you back the x value. Okay, that's basically what this is. So let's try a different one. Let's say we have f of x is equal to x plus 4 over x plus 2. So we say let y equal to x plus 4 over x plus 2. Interchange x and y, so we have x is equal to y plus 4 divided by y plus 2. Then we make y the subject, so we get is xy plus 2y. Okay, actually let me do it simple so you all can understand exactly what I do. So I'll do x, so we multiply and throw it by y plus 2. This will give you y plus 4. Then we'll have xy plus 2x is equal to y plus 4. Again, if you want to make y the subject, we put all the terms with y on one side and all the other terms on the other side. So what we have is xy minus y is equal to 4 minus 2x. Okay, then we factor in out y here. We get x minus 1 is equal to 4 minus 2x. Therefore, y is equal to 4 minus 2x all over x minus 1. And you see, therefore, f inverse of x is equal to 4 minus 2x all over x minus 1. Okay, and that's pretty much it for the inverse of a function and one-to-one functions. Okay, that's really all you have to do. Again, remember, for the inverse of a function to exist, it must be one-to-one. Okay, the domain becomes the range. So if I tell you the domain of, so let's say I have a function, right, and I tell you that the domain of f of x is 1, 2, 3, and the range of f of x is 7, 8, 9. For the inverse of a function, this becomes the domain for the inverse function, and this becomes the range of the inverse function. So it switches. Okay, and remember, if you want to obtain the graph, you just reflect it along the line y is equal to x. And remember, for a one-to-one function, just do the horizontal line test, or find f of a and f of b, put them equal to each other. If you get a equals to b, then it is a one-to-one function. Okay, and for a one-to-one function, every element in a has a unique value in b. Okay, and that's it for the topic of injective functions and inverse functions. Thank you for watching.